In the last section, we looked at trigonometric functions of acute angles, so those would be angles between 0 and 90 degrees. And now we're going to be looking at non-acute angles. And the reason we need to look at non-acute angles is most angles do not lie between 0 and 90 degrees. So in order to work with these trig functions, we need to be able to find what we'll call reference angles. So the idea of finding reference angles is going to be very, very important. Finding reference angles is going to be a very good skill to have. Knowing the values of those 30, 60, 45 degree angles is important. Reference angles is right up there with that as well. So we'll write the formal definition and some notes about reference angles, and then we'll do a lot of problems. So a reference angle, and again this is the formal definition, a reference angle for an angle theta, we'll say. And the reference angle, a lot of times they denote theta prime then. I usually just write reference angle. It's basically the acute angle, and it's always going to be acute between 0 and 90. And it's the acute angle formed by the terminal side of theta, and again we'll look at some graphs of these to make this a little bit easier definition. The terminal side of theta and the x-axis. And after you see us find a few of these in the lecture, they're going to be a lot easier than kind of looking at this definition. Now a couple of quick important things to remember. Reference angles are always positive. So if you find a reference angle and it's not positive, you have something wrong. And they're always between 0 and 90 degrees. So these are two important things to remember about reference angles. Okay, so to get started, let's go ahead and just start looking at some examples. So for our first one here, let's go ahead and find the reference angle for, let's do 218 degrees. Now always a curve sketch will help here, or a sketch of the angle. And this one again is theta equals 218 degrees. Okay, so if we look at our Cartesian coordinate system, this is a positive angle, so let's move in the positive direction. So we're going to start at 0, we're going to move to 90. Then next we're going to move to 180. And then if we go clear to 270, that's too far. So 218 is somewhere over here in quadrant 3. So this is 218 degrees. The end, or the terminal side, is in quadrant 3. Now if we look at the definition up here, it says a reference angle for an angle theta, written theta prime, is the acute angle formed by the terminal side of theta and the x-axis. Well, this is the terminal side of theta right here. So here's the terminal side of theta. So the distance from the terminal side of theta to the x-axis, this is theta prime. Well, how could I figure out what that is? Well, again, this is 218 degrees here. So I need to figure out how far is it from 180 to 218 degrees. And there's many ways we could do this. You could just count up. You could say, well, 180 to 200 is 20 degrees, and 200 to 218 is 18. So 20 plus 18 would be 38 degrees. Or you could just subtract here. Don't get in the habit of just subtracting all the time, because subtracting is not what always finds our reference angles for us. So if we do subtract here, we have 38 degrees. So our reference angle is 38 degrees. Okay, so that means any information that I want to find out about 218 degrees, I could use 38 degrees in its place, a smaller angle, and then just remember that 218 degrees lies in the third quadrant. And so that's how we can find reference angles real quick. Let's go ahead and look at one with a negative measurement. We could spin around in the negative direction. So this one, let's go ahead and find the reference angle. Let's do for theta equals negative, we'll just pick some big numbers, negative 1387. Now, again, we're going to want to draw a picture here. We'll have our Cartesian coordinate system. We're moving in the negative direction. So if we start here, obviously this is more than 360. So we could go negative 360. We could spin around another time, and that's going to put us at negative 720. I'm still not up to negative 1387. Another spin around would put us at, except I'm moving in the positive direction, I need to move in the negative direction. So negative 360, negative 720, and one more spin around would be a negative 1080. And now I'm getting pretty close. What is left over? How many degrees do I have left to use? I can't get another 360 here. This is negative 1080. It's kind of hard to read. I have, it looks like a negative 307 degrees left. So if I take 1387 minus 360 minus 360 minus 360, because I did 3 spins around, I'm going to be left with 307 degrees here. So I need to keep spinning around 307 degrees. Now if you want to think about this using the negatives, you could say negative 1387 plus these, and I still need to rotate around a negative 307. That's not my reference angle, but this would be negative 90. This would be a negative 180. This would be a negative 270 for that final spin. And then negative 307 would be somewhere around in here. So again, if I spun all these blue curves and then this final spin around would leave me at negative 307, it's in the same terminal position as negative 1387. So the amount of spin is different, but the terminal side is the same. So now in order to find my reference angle, the reference angle is the distance from the terminal side to the nearest x-axis. This is reference angle, or theta prime. Now there's several different ways that we could find this, but basically what I want to know is how far was it from 270 to 307? Well, if I look from 270 to 307, that looks like to me it's 37 degrees. Now, again, reference angles are always positive, so I don't have to worry about the fact that this is a negative angle that I'm looking at up here. If I want to figure out my reference angle, then theta prime is my reference angle. That's going to be 90 degrees minus that 37 degrees that I rotated in, and that leaves me with 53 degrees for my reference angle. That's this distance right here, 53 degrees. So there's a lot of different ways that we can try and figure these out, but I think a picture is a good idea. We want to subtract 360s until we get, these are additions here, we want to subtract 360s until I get something less than 360, and then rotate that around, figure out which quadrant I'm in, and then go ahead and draw the terminal side, and then see how far it is from the terminal side to the nearest horizontal axis. So again, our reference angle would be 53 degrees. Let's go ahead and look at quite a few examples from my math lab, just so you're kind of familiar with the types of problems that you'll be seeing in the homework. So for this one, we're going to be asked to find a reference angle. So it's going to be similar to one that we've already worked. And it's for 744 degrees, which is more than one spin around the unit circle if we're thinking about the amount of rotation here. So I think that's the first thing we need to start with. I already know that one spin around is 360 degrees and 2 spins is 720. So let's kind of start with that idea. This is moving in the positive direction. So here would be 360 degrees. Another spin around would be 720 degrees. And then how much is left over then is 744 minus 720. Again, minus 360 minus 360 is going to leave us with 24 degrees. So the amount that we're left with here, the amount of rotation then, is about 24 degrees. So this is 744 degrees. The amount of rotation that we completed here past the 720 was 24 degrees. And the distance from this terminal side to the nearest horizontal axis is that 24 degrees. So for my reference angle, that's equal to 24 degrees. And that's easier to work with than the large angle 744 degrees. So let's go ahead and look at a few more examples. And again, I want to make sure you have lots of examples to look at, so that way when you get to a problem that you'll have lots of examples to look at. Our next one says, let's go ahead and find the reference angle. Oh, that one looks a little too easy. Let's find one that's more difficult. Let's look at a reference angle for negative 124 degrees. So I'll pop this one in here. So the first thing we'll want to do is draw the angle. This is moving in the negative direction. So let me make sure this time I get rotating in the correct direction. So if I start at 0 degrees and I rotate through, the first quadrant I'd hit is negative 90. I still need to keep going, but I don't need to go clear up to negative 180. So negative 124 lies somewhere in here. So this is negative 124 degrees. Now, a common mistake to make for reference angles is to just go to the nearest axis, not the x-axis. But you never go to the y-axis, you always go up to the x-axis. So this is our reference angle, the positive, because remember we're always looking at positive values between 0 and 90 degrees. So a couple thoughts I have on this one. If we wanted to, we could take 180 minus 124 in this case, or negative 80 plus a 124, trying to figure out what that is for rotation. Another thing that we could do is we could say, well, here we are at negative 90. To get from 90 to 24, to get from 90 to 124, or negative 90 to negative 124 is negative 34 degrees here. Well, we know that this total quadrant is 90 degrees, so I could find that reference angle by taking 90 degrees minus 34 degrees to see what we would get here. So if I took 90 degrees minus 34 degrees, I would have 56 degrees for my reference angle. So this is 56 degrees here. Another way we could have done this is by taking 180 minus 124, and we would get the same 56 degrees. Okay, but again, it doesn't always just work to subtract the angles. So I think that a picture in this case, a sketch of what's going on, is going to be really helpful. Okay, I think we've already done some of the ones with the bigger angles. So let's go ahead and now talk about what about if our reference angle is a common angle, one of those angles like 30, 60, or 45. If that's the case, then we can find the trig functions, all 6 of the trig functions. So if the reference angle is a common angle, and sometimes they call them special angles, and again, I'm talking about 30 degrees, 60 degrees, or 45 degrees. Then you can find the related trig functions. And when we do these, we always want to have the exact answers. And that doesn't mean a decimal carried out to many places. That means using a fraction or a radical. So keep that in mind. We don't want to just plug these into your calculator to get an answer out in decimal form. These need to be in exact form. So if you just use your calculator for decimal form, they'll be counted incorrect. So make sure you have an idea of what's going on here. So for this example, let's go ahead and find the exact values of the trig functions. And again, exact values means square roots and fractions. And let's do this for theta equals 330 degrees. Well, that's not a special angle. That's not a 30, 60, or 45. But if I graph 330 degrees and try and figure out which quadrant I'm in and find the reference angle, that might help me figure out what's going on here. So let's go ahead and graph 330 degrees. So here's 90, 180, 270, 360. So I can tell that 330 will lie somewhere in between the 270 and the 360. So that's going to sketch it in here. So this is 330 degrees. So for me to find this reference angle right here, this positive value, I need to know how far it is from 330 to 360, and that's 30 degrees. So this is theta prime, that reference angle. So a way we could have done this is to take 360 minus 330 and get 30 degrees. But again, subtraction doesn't always work. So you need to be able to make sure you have another way to do this. Another way to look at this would be from 270 to 330 would be 60 degrees right here. And then I know to figure out the complement of 60 would be 30 degrees. So that would be another way we could work this. Now I'm in quadrant 4. So this is important. So in quadrant 4, I know that the cosine of theta is positive, and I know that the sine of theta is negative. So I can't just find all of the trig values for 30 degrees and call it good. I need to make sure that I realize that I'm using 30 as the reference angle, but I actually need to find these values for 330 degrees. So let's go ahead and sketch these up. So I could find the sine of 330 degrees, and I know right away that it's going to be a negative value. I know it's going to be negative because I'm in quadrant 4. Now what I can do here then is I can think about this as saying, well, this is just going to be the negative of the sine of 30 degrees because that's my reference angle. Well, the sine of 30 degrees is one we have memorized as 1/2, so I know that the sine of 330 is a negative 1/2. And because I know the sine of 330, I also know the reciprocal identity, so the reciprocal of sine is cosecant. So I know that the cosecant of 330 degrees is the reciprocal of negative 1/2, which is negative 2. So let's go ahead and look at the cosine next. So the cosine of 330 degrees is going to be the positive, because cosine is positive down here. It's going to be the positive cosine of 30 degrees. It's going to be positive, and the cosine of 30 degrees, we have that memorized, is the square root of 3 over 2. And of course, when you enter this in My Math Lab, you don't put in the positive sign, you only put in a sign if it's negative. Now we also know the reciprocal of cosine is secant. So I know the secant of 330 degrees is the reciprocal, so that would be 2 over root 3. And then of course you'd rationalize the denominator. So that's 2 root 3 over 3. Now our last one to find is tangent. So the tangent of 330 degrees is going to be the negative tangent of 30 degrees. And the reason we know it's negative is we are in quadrant 4, and I have cosine is positive, sine is negative. And since tangent is the ratio of those, the ratio of negative over positive is negative. So that's why I know that this is negative right here. Okay, so negative tangent of 30. Now this is not one I have memorized, so it's going to be negative, and I think about this as sine of 30 over the cosine of 30, which we have above, so that won't be difficult. The sine of 30 was 1/2, and again I have the negative sign that I'm dragging along. The cosine of 30 was the square root of 3 over 2. So this is negative 1/2. When you divide by a fraction, you multiply by the reciprocal, and I'm left with negative 1 over root 3. And of course, we'd rationalize that denominator, and I finally end up with that the tangent of 330 degrees is equal to negative root 3 over 3. Okay, so now that I know tangent, I know cotangent is the reciprocal. And so if I come right back to here, this was the tangent. The reciprocal of that would be a negative root 3. If I reciprocate here, then I'm going to have to go back through and rationalize again, and I'll get right back to where I started. So I'm just left with negative root 3. So sketch the angle, figure out which quadrant you're in, determine values of sine and cosine and tangent that are positive and negative, and then apply those based on your reference angle. But you have to remember which quadrant you're in for this to work. Let's go ahead and look at another example of the same thing. And again, curve sketch is important first, and then we kind of work through from there to figure out which quadrant we're in. So find the exact values of the trig functions on this one. Let's do a negative angle. Let's do theta equals negative 495 degrees. Okay, so to get started here, again, we want to sketch. Now, one of the most important things that we can do here is to figure out if this is more than 360, how many times do I end up spinning around this unit circle? So if we think about 495 degrees, I know I'm going to be moving in the negative direction. Here's a negative 90, negative 180, negative 270, negative 360. So I know I'm going to go a full spin, and then what do I have left from 360 to 495? Well, let's go ahead and subtract. Let's take 495 minus 360 to figure out how much we have left. So it looks like I have 135 degrees left. So I need to keep going 135 degrees in the negative direction. So here is 90, and then I need to go another 45, it looks like, right into here into quadrant 3. So this is negative 495 degrees, the full rotation. Just this bit right here was a negative 135. Now my reference angle is the distance from the terminal side of the angle to the nearest horizontal axis. So I'm at 45, so this was 135, so this is 90, this is 45, so this has to be 45 degrees. Now another way I could have figured that out is I could have taken, subtracted 90 here, and I would have been left with 45 degrees, but that's not my reference angle. It's this value right here, and it happens to be, since it's half the quadrant, that the other reference angle is the same value. But if this was subtracting anything else and getting anything other than 45 degrees, it would not be my reference angle. It would be this value right here. So those are a couple different ways that you can look at finding your reference angle, but a curve sketch is important. Now down in quadrant 3, what do we know? We know cosine is positive. I'll just say greater than 0. Positive. Sine, no, actually it's not. Cosine, we're in quadrant 3. Cosine is less than 0, so that's negative. Cosine is less than 0. Sine is less than 0. That means negative. And tangent is the ratio of the sine over the cosine, so a negative divided by negative would be a positive. Okay, so I should be able to find all of my trig functions from here. So what do I know about sine of 45? I know the sine of 45 is square root of 2 over 2. I have that memorized. I also know that the cosine of 45 is the same. It's the square root of 2 over 2. And I know the tangent is the ratio of the sine over the cosine. So square root of 2 over 2 divided by itself, square root of 2 over 2 is 1. Now for this angle of negative 495, I need to use this reference angle. So reference angle is 45 degrees. Okay, so let's look at this. Sine of negative 495 degrees is going to be the negative, because I have it down here, of the sine of 45 degrees using my reference angles. So this is going to be negative square root of 2 over 2. And because I know the sine, I know the cosecant of negative 495 degrees. It's just going to be the reciprocal, so negative 2 over root 2. Of course, we rationalize. 2's cancel, I'm left with negative root 2. Let's do the same for the cosine of negative 495 degrees. From here, cosine is going to be negative. So this will be negative cosine of 45 degrees. Because I don't want to memorize all multiples of special angles. That would be very difficult. And then I know the secant will be the same as the cosecant. And actually I know the cosine would be the same as well. And then tangent of negative 495 degrees is going to be positive. So I'm going to just put a plus sign there. When you enter your answers in My Math Lab, don't put a plus sign. I just want to put it here so we remember to check. And that would be sine over cosine. And we already know from sine over cosine, from up above, if we want to write it out, square root of 2 over 2, square root of 2 over 2. When you divide by a fraction, you multiply by the reciprocal. So here I'm left with a positive 1 for tangent. And of course, cotangent would be the reciprocal of that, and the reciprocal of 1 is 1. So the cotangent of negative 495 degrees is is positive 1. So that's an example of how you can use reference angles to find all the values of your trig functions when you're given what they call special angles, or I call common or standard angles. So let's go ahead and pull out some problems from My Math Lab, just because there'll be some familiar things that you're going to be looking at. Now, you're not always going to be finding all 6 of the trig functions. Sometimes you're just asked to find sine, cosine, or tangent. So for some of these, we'll just get started with setting it up. And then once you have it set up, you could probably find the rest if asked. So for here, let's find the exact values of all the trig functions. We might just do the first couple of negative 225. Okay, so for negative 225, let's sketch that. We're moving in the negative direction. Just have to figure out which quadrant we're in. So here we're at negative 90, negative 180, negative 270. So negative 225 is right in between here somewhere. So here's negative 225. So here's the terminal side of that angle, and my reference angle will be this distance right here. So if I look at this, and I want to figure out what's going on here, I could take, let me see, I could be at 180. 180 to 225, it would be 45 degrees. So again, this is that negative 225 degrees. So my reference angle, theta prime, is 45 degrees. And I'm in quadrant 2. Okay, so in quadrant 2, I don't have enough room here. Cosine is positive. I did it again. Cosine is negative, less than 0. Sine is positive. And tangent then, because the signs alternate here, would be negative. So when I write out my trig functions, I know they're going to be square root of 2's over 2's, and everything from this, what I had up here, using these values, the only difference being some of them will be positive and some will be negative. Okay, so let's set these up. Let's look at the sine of a negative 225 is going to be a positive square root of 2 over 2. It's going to be positive because I'm in the second quadrant where sine is positive, and the reference angle is 45 degrees, so the sine of 45 degrees is square root of 2 over 2. And I would also know the cosecant of negative 225 then would be the square root of 2. I'd flip this, and then I would rationalize the denominator. The cosine of negative 225 is going to be negative because I'm in the second quadrant, and the cosine of 45 is square root of 2 over 2, the reference angle. Then I know the secant of negative 225 is the reciprocal of that rationalized would be a negative root 2. And I have the tangent of negative 225. Tangent is negative. And then the cotangent of negative 225 would be the reciprocal of negative 1, which is negative 1. So these are pretty quick and pretty straightforward to find once you know those standard angles. Now, if you don't know your standard angles and the sines, cosines, and those functions of them, you're going to have a tough time. Now, sometimes instead of being just said find the values, sometimes you're going to be given a table. So let's look at an example where we're given a table. Hopefully we haven't seen this angle before. The one that popped up was 210 degrees. So they give us the sine, and they give us the tangent, and they give us the cosecant. And actually, we could probably figure out the rest from there. For instance, we could figure out the cotangent by just taking the reciprocal. But let's just go through the process of sketching the angle and working from there. So 210 degrees is our angle. Well, if we sketch our angles here, we have 90, 180, and 270. And 210 degrees is somewhere in between 180 and 270, so this is 210. So how much further did I rotate past the horizontal to get from 180 to 210? And that answer is 30 degrees. So that's my reference angle. Now I'm in quadrant 3, where the cosine is negative, the sine is negative, and the tangent, the ratio is positive. So when I go through here and find all of these values, then I'm just really working with 30 degrees. So I see this is sine of 30 degrees is listed, or the sine of 210 is listed, but let's go ahead and see how that was calculated. I am negative because I'm in quadrant 3, and then this would be the sine of my reference angle, which is 30 degrees. So this would be a negative 1/2. So that's where that came from. And of course, cosecant then would be the reciprocal of negative 2. Now let's go ahead and move down to cosine, the one that we're actually trying to find. Cosine is negative in quadrant 3, so this is going to be a negative. And I have this memorized is going to be the negative cosine of 30. And I have that memorized to be the square root of 3 over 2. So this up here should be negative square root of 3 over 2. Now, if I know the cosine, I also know the secant is the reciprocal. So that would be negative 2 over root 3. And then I'd rationalize it, and that's negative 2 root 3 over 3. So secant would be a negative 2 root 3 over 3. Now I could figure out tangent from here if I wanted, or I'm given already that the tangent of 210 degrees is the square root of 3 over 3. So I know automatically that the cotangent of 210 degrees is the reciprocal of that, which is 3 over root 3. And then of course we'd rationalize it, and I'd have 3 root 3 over 3 cancel, and I'm just left with root 3 here then. So this is an example of how we could fill these out by using a table to summarize our values instead of just listing them all. For the rest of the lecture, we're just going to be working through a lot of the different types of problems that you're going to be seeing in your homeworks and quizzes from this section. So this one says, determine whether the statement below is true or false. Sine squared of 30 degrees plus sine, or cosine squared plus of 30 degrees plus sine squared of 30 degrees equals 1. Well, we already have a trig identity. It was called a Pythagorean identity. And it's one that we'll definitely want to have memorized, that said sine squared of theta plus cosine squared of theta equals 1. Now, what is important here, addition doesn't matter. So whether we start with cosine or sine and when we add them together, it doesn't matter. What matters are these angles are the same. So over here, since these angles are the same, this is a true statement. Now, if it had said cosine squared of 30 plus sine squared of 45 equals 1, that wouldn't be true. But just to verify, let's go ahead and plug in our values. So what is the cosine of 30? That was the square root of 3 over 2. What is the sine of 30? That was 1/2. And we want to know, does this equal 1? So if we square root 3, I would get 3. If we square 2, I'd get 4. If we square 1, I have 1. If I square 2, I get 4. 3/4 plus 1/4 is 4/4, which equals 1. So this checks. That is a true statement. But it's based on this Pythagorean identity. And in order for that to be true, both angles have to be the same. I can't have the angles to be different and still have that work out. Okay, so let's go ahead and look at another problem. And again, with a lot of these, you just have to kind of work through them. But I just want to make sure that you're familiar with the process that we want to approach these with. So here it says, determine whether the following statement is true. Well, the best way to determine if it's true is to actually work the problem and see what we get. So this would be the sine of 135 plus 45. That would be 130 plus 140, 170 would be 180 degrees. And we want to know, is this equal to the sine of 135 degrees plus the sine of 45 degrees. Well, right away I know this is false because already I know that the sine of 45 degrees is the square root of 2 over 2, and the sine of 180 is 0. That's a quadrantial angle. So let's look at the sine of 180 real quick. Here's 180 degrees. Remember when we put these points up, let's say as -1, 0, the sine would be 0 over r. R in this case is 1, so 0 over 1 is 0. This is one of the quadrantial ones you'll want to have memorized. So I get 0. The sine of 135, so here's 180, here's 90, here's 135 degrees. The reference angle for that is 180 minus 135, in this case is 45 degrees. And the sine is positive in quadrant 2. So this is the square root of 2 over 2. So if I add these together, I'd get 2 root 2 over 2, which cancels to leave me with root 2, which does not equal 0. So that is a false statement. So what this is saying is I can't take these values and split them up into two separate expressions. I can't take the sine and distribute through. That does not work. So never distribute through the argument of a trig function is basically our lesson there. Let's find another one to look at. This one looks like an interesting one. This one asks us to find the coordinates. Usually we're given the coordinates. So this one we're asked to find the coordinates. So find the coordinates of the point P on the circumference of the circle. And it doesn't look very circular, but that's just because I have this distorted. It looks a little better. It says, hint, add x and y axes and assume the angle is in standard position. Okay, so we're going to go ahead and just rewrite this. It's kind of more in the quadrant 2, so I want to leave a little bit more room to work in quadrant 2. And this is 150 degrees. So this is 90, and this is 180. This is 150 degrees, and so our reference angle is this distance right here, which is 30 degrees. And we're looking for this point P. And this value of 6 is this radius. It's from the center to that point P is this distance of 6. So if I drop in altitude, you'll see some familiar things appearing here already. So what I want to do next is I just want to realize that with this point P, the x value is going to be negative and the y value is going to be positive because I'm in quadrant 2. Okay, so keeping that in mind, let's go ahead and blow up this triangle a little bit. So here's my 90, here's my 30-degree angle, and I know that this is 6. Well, let's think about this. The sine of 30 degrees is the opposite over the hypotenuse. And this opposite side, I don't know. So if I don't know this opposite side, I'm just going to call this A. So opposite side would be A over hypotenuse is given as 6. But I know that the sine of 30 degrees for any triangle with any hypotenuse length is going to be 1/2. So note, sine of 30 for any right triangle with a 30-degree angle is 1/2. So if I set this equal to 1/2 and then I solve, I'd cross multiply to get 2a equals 6. Divide both sides through, I'd get a equal 3. So I'd get a equal 3. And then to find this other missing side, we'll call b. So for b, I would use a squared plus b squared equals c squared. So 3 squared plus b squared equals 6 squared. So here I'd have 9 plus b squared equals 36. B squared equals 36 minus 9 is 25. B equals, take the square root of both sides, plus or minus 5. Now we know we're in quadrant 2, so I already know that b has to be a negative value, so it'd be a -5. So I'm going to choose the negative because I know I'm in quadrant 2. So this would be a -5, and this would be a 3. So if I come back up to find this point, then I'd have my x is -5 and my y is 3. So this would be the ordered pair -5, 3 for my solution. So it's kind of just working backward. And again, if you don't have any knowledge of your unit circle, that's going to be a difficult problem to work, just because you don't know to start with that the sine of theta, or the sine of 30 degrees, is 1/2. And if you don't know that, then it's a difficult problem. Let's go ahead and look at another example. This one gives us a value for tangent and it asks us to find the angles. Now, thankfully, this is a familiar value of tangent. So it says find all the values of theta in the interval 0 to 360 that have the given functional value. Tangent theta equals -1. Well, I know a couple things. I know that the tangent of 45 degrees is equal to 1. So that means whatever I come up with here has to have a reference angle of 45 degrees. So if I sketch this out, I have to think, where is tangent negative? Where is it less than 0? Well, it's going to be where the signs change or alternate. They're not the same. So that's going to be in quadrant 2 and quadrant 4. So I need some quadrant 2 angle that has a 45-degree angle as my reference angle. So that would be 90 degrees, and this would have to be plus another 45 degrees in order to have my reference angle here. So 90 plus 45 is 135 degrees. So my quadrant 2 angle would be 135 degrees. So the tangent of 135 degrees is equal to -1, because remember, I wanted a -1 here. I'm just using the fact that the tangent of 45 is equal 1 for my reference angle. Now I want to do the same thing for quadrant 4. Okay, so for quadrant 4, what I'm going to do is I know I'm going to have to come around, and I know I want this reference angle right here to be 45 degrees. And I know that this is 360 if I go a full spin around the unit circle. So that means that this purple angle that I just drew would be 360 minus 45, which is 315 degrees. So the fourth quadrant angle would be 315 degrees. So the tangent of 315 degrees is equal to a -1. So this is another way that we can use those reference angles to kind of help us out, and also use our knowledge of the unit circle. Because again, if you don't know the unit circle, and this is that circle that's moving 360 degrees, and your quadrantial angles and those special angles, it's going to be harder to work with these. So as you're working through the rest of the problems for this homework assignment, those are the things that you need to keep in mind. You need to keep in mind your knowledge of the unit circle, your knowledge of the special angles, your knowledge of your quadrantial angles, your quadrants, meaning what quadrant are you in, at what time, and what are the signs for the sine, cosine, and tangent in terms of positive and negative. So hopefully this has gone through quite a few different problems, so your homework set won't be very complicated. But if I were you, I'd really start memorizing your special trig angles that we just talked about. And I would also start looking at your quadrants to make sure, excuse me, to make sure you know if sines, cosines, and tangents are positive or negative. And then I'd also make sure I know the sine, cosine, and tangents and the reciprocal functions for your quadrantial angles as well. I think I'll probably make up in your handwritten homework for this next section, a table for you to fill out. And again, it has to be one that you have memorized. So good luck on this section as usual. If you have any questions, please let me know. Don't hesitate to shoot me a text.